Everything's working well. Okay. All right. So we did sine, we did cos last week. We did this one last week. I kind of rushed it towards the end, but we're going to do the exact same. Well, we'll do that one right there, sine. So we will do sine. Just make sure. Yep. So we're literally just going to do 7a. Copy. Did I turn the recording on? Yep. All right. Okay. So the idea with reduction formula again is just to find a formula. There it is. That allows me to find the integral of any power n. So any integral that I want. If I wanted I5, which means sine x to the power of 5, right? It's useful because anything past 2 is really hard to actually integrate. In fact, it's almost impossible to integrate without doing integration by parts, which means you might as well have found it through a reduction formula. All right. So n equals the integral from 0 to pi on 2 of sine x to the power of n, or sine, n x. And what we have to do, we've got to use integration by parts to somehow integrate this. And what we didn't exactly just use this. We broke this up. Does anyone remember what the next line, or what it should be? The next line would be written like this: sine x with sine x to the power of n minus 1. So what you're doing, you're actually breaking this up into pretty much 2 different expressions. And the reason why we do that is because the first one has a single expression, which means if I was to do integration by parts, obviously you would have chosen that as your derivative, right? Sorry, sine x to the power of n as your derivative. And then your integral would have had to be what? So I'm not going to give you the answer. Tell me, what would the integral have had to be? So what would your dv be?
Yeah.
U is, yeah? I didn't hear that. Say that again.
Dx.
Dx. Exactly. So then what would happen when you were going to integrate this? You would have ended up with x, and then all of a sudden you're going to have x's, and so algebra with trig, and then you can, if you look at this, you're like, well, I'm never going to get that because that's just my trig takeaway 2. So wrong, won't ever work. And then, algebra with trig, trying to integrate that when you do your u, v, minus, it just will not work. Instead, you realize, okay, what I can do is I can actually split this up. My u becomes same thing. It's still this guy here, which is what you would have chosen. But my dv, instead of it being just dx, it's actually now going to be sine x dx. And the reason why that's really smart is because when you go on to integrate, and then eventually, you're going to do v times du for our integral sign, At least it's trig with trig, not algebra with trig. Right? That's really bad. If you can avoid that, you want to avoid that. So that's the trick. For sine and cos, they both work the same way. You break them up into cos and then n minus 1, or sine x and then sine x n minus 1. So exactly the same for both sine and cos. For tan and sec, no, it's different. So sine and cos, make a note of it, it would be n minus 1. Or break it up like this. For tan and sec, it would be a bit different. It's obviously going to be sec squared, for those who understand that, because you know the integral of sec squared. All right, let's go. du becomes n minus 1 times by sine x, using chain rule, n minus 2 times derivative of sine, which is cos x dx, right? Look at it. Going down is differentiation, going up is integration, derivative of the inside is positive cos. What is the integral of sine? Integral of sine is negative cos x. Negative cos x. All right, before I continue, any questions about that line? All right. Limits. When we do u times v, we include the limits. So it will look like this. Negative cos x times sine x to the power of n minus 1 pi on 2, 0, minus integral 0 to pi on 2, these two multiplied. Now, look at the way I do these again. Negative and a negative makes it into a positive. Cos times cos becomes cos squared, sine n minus 2. And what do I do with the n minus 1? I usually like to write constants in the outside. So n minus 1, then integral 0 pi on 2 cos squared sine x n minus 2 dx. And it's okay to do it like the way I just showed you guys. So work on the ones that are annoying first, like the negative and the negative, make it into a positive. You know cos and cos, that becomes cos squared. And then you realize, oh yeah, I've got my constant still, put it in the front. It's not a problem. You don't have to pick up everything at the beginning. All right, next line, sub in 90. Cos 90 would give you 0. 0 times anything is 0. Minus sub in 0. Cos 0 is 1, but then sine 0 will give you 0. So that's just 0 minus 0. Nice. That makes it a little bit easier. You know that that should have happened. You can see there's no plus sign here. It's not plus anything else. Okay, so it's just the integral, which means it'll just be the integral bit. All right. Plus n minus 1. Integral 0 pi on 2 cos squared x times sine n minus 2x dx. Okay, Mariette, what would be the next line? N minus 1, 0, pi on 2. What would I do? What can I change here?
The cos squared x, you can turn that into sine.
How?
Is it sine minus 1 or sine plus 1? Is that
Nope.
one?
Nope. You're close. Like you're close. Cos squared x. Say it out loud.
Is it sine squared minus 1?
Ah, close. That's what I try to say. Say it out loud. Yeah, 1 minus sine squared. Because you know cos squared plus sine squared equals to 1. So then, if you're going to bring your sine squared to the left-hand side, it'll be 1 minus sine squared x equals cos squared x. All right.
Yeah.
Sine n minus 2x dx. Okay, next line. N minus 1. Integral 0 pi on 2. 1 times this. minus, what's sine squared x times sine n minus 2x? What do I do? If the bases are the same, what can I do the powers? N minus 2 plus 2 n x dx. Okay, I'll just pause there. Any questions, you guys? Have I absolutely lost anybody? Anyone absolutely confused going, I don't know, what is happening here? Please, you gotta let me know now. I need to know. No, we're okay. Everything's making sense. I understand how I'm getting every single line expanding. All right. Then next line. Next line is to understand this is n minus 1 multiplied by this and n minus 1 multiplied by this. So n minus 1, 0, pi on 2, sine n minus 2x dx minus n minus 1 integral 0 pi on 2 sine n. All I did is I split up my integral sign so that you guys can tell that that's one and that's the other one. So, but don't forget, both of them have to have n minus 1. So n minus 1 times this, there it is. N minus 1 times this guy, there it is. Okay, yeah? Any questions?
Sam, could you explain that line one more time?
Yes. So if I had, I'll just do it down here. If I had n minus 1 integral from 0 to 1 of x take away, x plus, we'll just make it, x plus sine x and then dx, right?
Yeah.
This integral sign is the same as me writing n minus 1, open big brackets, the integral of x plus the integral of sine x.
Sine.
That makes sense, doesn't it?
So you basically, okay. Yeah, that does.
If you've got, like, I mean, you could have integrated this, but what would the integral of x be? You would have said, oh, x squared on 2. Well, what's the integral of x here? Still x squared on 2. What's the integral of sine? You would have said negative cos. What's the integral of sine?
Oh.
So it's exactly the same. Instead of writing it as one combined, I'm splitting it up just so it's a bit easier to see. And then, of course, expand this and expand that. So I did that in one line. I understand if I've got two things, I can separate the integrals. Mm-hmm. There it is. And then multiply both of them by n minus 1.
All right. Sweet. Thanks.
Make sense?
Yep.
Control Z, 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 Z. Good question. Thank you, Ben. Anybody else have any questions? Don't be shy.
Sam?
Yes. Yes.
From the third to the fourth line, did you just
Third.
expand the brackets?
Is this third? This one here?
Yes, that one.
Third to the fourth. Did I? Yes. All I did was 1 times sine n minus 2x. There it is. Minus sine squared times sine n minus 2. What do you do to the powers if the bases are the same? We can add the powers. So, yep, n take away 2 plus 2 is just n.
Okay. Okay, thank you.
Make sense?
Yeah.
Yep, no. And then here, I split them up. From this line to this line, I just changed cos squared, became 1 minus sine squared. From this line to this line, I kept everything the same. I just substituted my limits. Because at least that way you don't have to keep writing this. Seen a lot of my students get taught by their teachers to keep this until the end when they're about to do worst decision. Do not keep this. Substitute this in. Most of the time you'll realize it's going to be zeros or ones. So get rid of it. Why do you want to keep writing this big thing? So sub it in straight away and then start dealing with this side. Here, you would have expanded. Naturally, you would have expanded. Here, I'm just trying to teach you guys, if you've got 2, 3, 4 terms, you're allowed to split them up. It just makes sense. You're integrating each one separately. Okay. Now, this guy, look at it, 0 to sine n x dx. That is exactly the original question. So just look at your original question. There. 0 pi onto sine x to the power of n. Exactly the same. So this guy can be written as what now?
IN.
IN. Because the question said IN is this integral. Perfect. So that, instead of me writing like that, I can just write as IN, which makes it a little bit easier to write. This one looks so close to this. In fact, the dx is the same, the sine x is the same, the 0, the pi on 2 is the same. Everything must be the same, except the n is now n minus 2. So that means this can be written as I n minus 2. Do I need to say that again in a different way? No, that made sense. The way I usually link this is think of functions. You know, if I said f of n and then f of n minus 2, it just means replace your n for n minus 2. This one looks like it's exactly the same as this one, except your n has been replaced for n minus 2. So your in can be written as I n minus 2. Or if you guys remember induction, when we did induction and we said, hey, let n equals to k, and then we did, hey, let n equals to k plus 1. Wherever you see n, you replace it for k. Wherever you see n, you replace it for k plus 1. It's pretty much the same idea. Okay, so now we're here. Now what do we do? We've got I, and the idea was to solve for in. So obviously, what are you going to do? You bring this in to the left-hand side. True? Remember, you're solving for in. You obviously will bring this guy over to the left. So it will look like this. In plus, and then I'm going to, I won't expand just yet, plus n minus 1 in. So close. If you guys remember what you were trying to prove, that looks so close to what we're about to get. I just want to find in. What would you guys do when you see this? If you just want in, it's up to you. What do you want to do?
Are you factorize and divide it?
Fair enough. That would be the best way. Some students would also have said expand this and then simplify. Both would work perfectly fine. So, in, you said factorize. All right, in, 1
Yeah.
plus, and then n minus 1, 1 for this, plus n minus 1 for this, equals, and you're done. This and this cancels out. You're just left with in, which means your answer is on n. Exactly what was required. Let me just quickly go up just to double check it. There it is, n minus 1 on n, in minus 2. N minus 1 on n, in minus 2. So I'll leave that there. Let me know what questions we've got. you guys are eventually, like I was even at your stage of math, if you're able to exit, you can safely say you are a pro at calculus up to university level. Okay, because this is some hard stuff, and it's hard because you've got to understand what you're doing in every single line. You know, a lot of different weird factorizing that you probably haven't seen before, a lot of letters. So if you're able to execute this, you can say year 11's done, year 12's done. Economics, finance, accounting, math, science, all of that, finished. It's as hard as you'll ever see it. Okay. Okay, done. Then, no, any questions? Double I. Find I8. Okay. What do I do? I'm sure someone would remember what you would do with something like that. I8. I need to find I8. Think about what you've just done. Why did you do all that? To work out a formula. So what would you write for I8? I8 equals?
Then sub in
Tell
8
me.
for n.
Say it. Go. Give me the answers I'm looking for. I8
8
equals?
minus 1 over 8
7 over 8. I
to the 8 minus 2.
I
6.
There we go. There, come on, let's go. Don't say 6 take away 1. Literally give me the answers I'm looking for. So I6 equals
I6.
yeah, I6. Come on. I6 equals. What's wrong?
Wait.
Well, what does n equal to now? If it's 6, I6.
Oh, I6 equals 4 on 6.
No, 5 on 6, you mean?
5 on
5.
6.
Yep.
I
4. And then I4 equals?
3 on 4 I2.
I2 equals?
1 on 2 I0.
And then you can't do I0 equals -1 on 0, I -2. There's two reasons for that. Obviously, you can't divide by 0. And your second reason is when you're going to get to negatives, that means you're trying to work out this, which is part of inverse trig. And to integrate inverse trig, we understand you've got to use by parts for that anyways. So this formula doesn't exactly work for any negatives. So 0 is the maximum, the absolute maximum you can ever get down to. You cannot get to negatives. -1 is not allowed, and obviously anything before that is not allowed. Cool? So, I0, you know the formula was this, and you can't sub in I0 into here. You've got to somehow work I0 out. So you're not going to sub it into this one, but then you had this. The actual original question. That's where you sub in I0. You can't sub it into here, sub it into the original. Make sense, mate, yet?
Yeah.
Anything to the power of 0.
1.
1. So what's your answer here? 1 dx. So what's the integral of dx?
X.
Does that make sense?
Yeah.
And then what do? We're trying to work out I8. So now you would write I2 equals
Pi on 2 on 2.
Technically, half times pi on 2. Yep. Pi on 4. Then you would write I what?
I pi on 2.
Oh, no. Now that you've got I2, then what's our aim? Our aim is to find I8, right? So we decrease
so
I8 all the way.
I4.
Yeah, and then once you find I4, what would you be doing?
I6, then I8.
And then I8. That's the logic. So I4 equals to 3/4 of I2, but I2 now we know is 3 pi on 16. I6 is 5/6 of 3 pi on 16. 15 pi on 60, 36, 96. And then lucky last of 15 pi on 96. And you're done. 105 on 80 times 96 simplifies to 35 over 256. 35 pi on 256. So you just worked out, 0 to pi on 2 sine to the power of 8x dx. Something that was pretty much impossible without you doing it via reduction formula. So if you didn't have this formula, there is no way you would have been able to do this and get through 35 pi on 256. And that's how this is being used. Okay. What I want to do is maybe just make you guys try to do a cos x question yourself before I do a tan x question again. So I just want you guys to try one on your own, or even that one. But that one's easy. I would like to do this again. We don't have to find I6. We can find a different one. And again, look at it. I mean, look at this term. It's exactly your sine, isn't it? So sine and cos are exactly the same. It's just instead of here you end up with cos squared, you're going to end up with sine squared. Exact same math. So I will give you the first line. I just want to see for you. Right, so your first line looks like this. In equals 0 pi on 2. Does anyone still want to copy anything above? Did I go too fast?
Yeah, I just need I8.
Yeah.
Okay, got it all, thanks.
Yep, all good. Okay, so cos n x dx. Okay. Next line. That I can't use off the bat. What I've got to do is just split it up into cos x and cos n minus 1x dx. Now I write u equals cos, if you guys want to just leave it like in chain rule form so you don't miss anything, find du. dv is cos x dx, and the integral of cos is positive. So try to see if you can continue from there. Okay, try to get the derivative out here using chain rule, and then try to see if you can write the integral and see which line you'll get stuck at. It's good to find this out. Okay, du. Bring the power down. Keep it the same. Take away 1 from the power. Differentiate the inside. The derivative of cos is negative sine. Next line, I would do that by these two. So open brackets, sine x times cos x n minus 1, high on 2 and 0. Minus, and then there's a negative, so again that becomes a plus. You start to learn to keep this in the outside, and then integral of 0 to sine times sine is sine squared cos n minus 2. Cos n minus 2 dx. Okay. Anyone still not able to get that, or confused about how we got that? Just needs help? Talk to me now. Did we do a mistake somewhere? Just want to double check something.
Is it negative sine squared?
But when I do negative here for the actual formula, right? It's this times this, minus this time, and then there's a negative. The two negatives makes it into a plus.
Oh yeah, you're right. Yeah, all good.
Anybody else? Next line, if I sub in cos 90, it gets me 0. And if I sub in sine 0, it will also get me 0. So again, this term just becomes 0 plus, and then what do you do at this stage? Sine squared would become 1 minus cos squared. And then obviously multiplied by that. So next line equals n minus 1 integral 0 pi on 2 of cos n minus 2x, and then minus cos squared 2 plus n minus 2 just becomes n, just like before, dx. And you know it's right because you've got a negative, so when you're going to bring it to that side, it's going to become a plus. Then we split up our integrals. If you get faster, you can just skip this line and write I n minus 2. But for now, obviously, I'm just right, so all I did is I expanded the n minus 1 and then split up this as two different integrals. This is I n minus 2. This is I n. Bring it over. Factorize, like Nook had said before, plus n. Do it in one line. Take your time, in plus n minus 1 in. So I just plus this over. Gives me n minus 1 in minus 2. Factorize 1 plus minus 1. You're left with just the n again, and exactly the same result like before. A bit easier, hopefully, second time round. Ask me any questions. No.
Oh, yeah, Sam, how many marks would these type of questions be worth?
This it's well, you know what, Enoch? This HSC. No point of me telling you, right? Why not find out? Let's go. You guys got to learn to do this for all of your subjects. No point of waiting anymore. Was it in last year's paper? Let's see. I wouldn't even remember now. It's usually at the end, so I think I'm just going to scroll down a fair bit. Look at that. What a question for extension 2 mathematics. That's just a basic year 11 advanced question. You know, so good, 2 marks. Really, really easy. And there it is. So how many marks? 2 for just to integrate, 3 for the reduction, 2 for that. So 5, 7 marks. That's a lot. But just the reduction bit would be 5 marks. The integral of this, which is pretty straightforward, is 2 marks. So, and what question was this? Question 15, second last question, which is what I said to you guys last week. It's usually going to be there. So anywhere from 5 to 7 marks. Look at that. You see that question? Let's see. Looks familiar? See? You do my questions, it's going to be in the exam. 2019 HSC. See that one? And it's either here or the other, in the other section. Yeah, I thought so. It's not in by parts, because it's not a by part question. But, just to make it clear, well, that one's even hot. There it is. And there it is. So those two, pretty much e2x on 1 plus ex, ex on ex plus e negative x. If you rearrange this, this pretty much becomes this one here. So you see, you don't need 1,000 questions, and I've told you that when we started. I said if you can complete all my questions, you are good. You'll be fine. I've covered everything in here. So there you go. See? So you can actually walk into your extension 2 exam going, I've already done all this. And you can get a raw mark of 90. Obviously, that's what all of the extension 2 kids do. That's how extension works. Extension 1 and extension 2. Advanced doesn't work like that. You know, I can't predict the question advanced because it's so vague. But in extension 2 and extension 1, if you get taught this, this will be in your exam. That's how it works. So, good question, Anouk, and there you go. I proved it for you. All right. Let's do a 10 question. Let's do a 10 question. Now let's do this question. Let's see how we go. All right, log. There is, so other than for trig, right? Other than trig, there is no trick to these. So there's, I'm not going to say, oh yeah, multiply this one by log x to the power of n minus 1. Obviously, you understand why there would not be a trick, because there is no, sine squared business that's going to happen for log x's. So there is no trick. You just of the question. It's just a normal question. You just start it. So in, let's try to do this question. So in equals the integral of 1 to e of log x to the power of n dx. So not only you can integrate log, you can actually integrate any power of log. And that's what this formula is allowing you to find. Okay, who wants to tell me what the u would be? It's not that hard. What would u be? And obviously, what would dv be? Quick. Quick, come on. What?
The ln x.
Just ln x?
Ln x to the power of n.
Beautiful. And what would dv equal to?
Just dx.
And then what's the derivative of ln x to the power of n? Chain rule. Ln x power of
n minus 1.
times by the derivative of log x, which is
1 on x.
beautiful. We've done it now. Memorized. And then what's the integral of dx?
X.
And then look what happens. What happens?
And then you've got to times u and b.
Yeah, but what happens here? I'm saying, what happens here?
Oh, the x cancels.
Say it again. Yeah, the x cancels, and see, so it's not that problematic. And look, ln x n minus 1, n minus 1, I n minus 1. All right, let's do it anyways. So equals, open brackets, x log x to the power of n e1 minus integral, bring the n on the outside, x and 1 on x, you're left with x to the power of n minus 1, exactly that. Look at it, looks exactly like the original question, except instead of n, it's actually n minus 1. So instead of it being this, we're going to write minus n in minus 1, exactly like what they wanted. What must the answer of this be, Mariette? This whole thing? What's going to become?
Pardon? You glitched out for me.
This bracket, what will this be equal to?
8.
Of course, right? Because you've already got minus n minus 1. You know this is going to be e. And then obviously you're going to sub it in. Log 1, when you do that, it's just 0. So that's why it's minus nothing. Log of e is just 1. And then so your answer is just e times 1. There you go. So it's like as if you just rewrote the question. How easy was that? All right. Any questions, you guys? See, that was a lot easier than the trig one. I started you guys off with the hardest one you're going to get. Yeah, you're welcome. Any questions? All right. Find I4 now. Stefan, you're going to do I4 for us. So just take your time, do it first. I'll give you about a few minutes. In is E minus N in minus 1. So I4 is E minus 4 I3. And then you're just going to keep going until you pretty much get to 0. So just keep going.
Well, you want me to say now, yeah?
No, not yet, not yet. Just work on it, write it on paper to make sure that you're comfortable with it first. Okay. Stefan, I3. Go.
Equals E minus 3 I2. Then I2 equals E minus 3 I1.
2I1, you mean?
Oh, yeah.
I said be careful. Okay, I1.
Then I1 equals E minus 1 I0.
Yep. And then, of course, you can't do I0. Why can't you do I0?
Just turns into, like, times by 0, so just equals E.
0 takeaway. It's not. That's not the problem. It's more this one. You're going to get 0 takeaway 1.
Oh, you can't get a
You
negative.
can't look for negative ones here. Yeah, that doesn't work. So it might be E, but unfortunately we don't accept it written like this. What you've got to do is go back up to the original. Cool? The original was 1, E, and then ln x to the power of n. Do you agree?
Yeah.
Now you're trying to find I0. Anything to the 0 is 1. So what are you actually integrating? Just dx. 1 dx, yeah. And what does that become? X. And what's the answer? Sub it in. What's your answer?
E plus 1. Oh, minus 1.
Minus. Minus. Highest one minus lowest one. See, so if it was E, it was wrong. It's actually E minus 1. And then what do you do now?
And then you sub it back in.
Here we go. So I1, go backwards. So E minus bracket, E minus 1. What's your answer? You probably can see it.
1.
1. Good man. Next one, I2. I2 is E minus 2 times 1, which is just 2. Easy. I3.
3.
Minus 3. And then E minus 2. Can you tell the answer from just looking at it?
2E minus 5.
Plus 6. Minus 3 times negative 2.
Oh, times.
You've got to work on that mental math. Perfect. I4. E minus 4. Try it one more time. I3. I3 is this.
Minus 3.
No. So first expand this in your head. What does that give you?
What? Negative 4,
Negative
negative 2.
Yeah.
Oh, negative 8E.
No. 8. Positive 8e.
Yeah.
8e plus e.
8E plus E. 9E.
9. And then?
Minus 6E.
No. This one times this.
Oh, negative 24.
That's it. If obviously you guys don't need to do this just yet, you know, but I'm trying to get you to like a year 12 extension 2 student while you guys are still in year 11. You're going to be working a lot of this algebraic expansion, but you know, it's good to work on your mentals so that you can skip lines and get things done a little bit faster. But that's good. And that's it. That's I4. Finished. That one there, Anouk, for example, that would have all been worth 5 marks. So still, same thing. 3 marks for the beginning, 2 marks for the end. Or 2 marks at the beginning and 3 marks at the end. It doesn't make a difference. All right, let's try another reduction formula. These are not reduction, so that's fine. Let's try an algebraic one. Do I have an algebraic one here? I don't, except that one. That one's going to be really, really hard. Really, really hard. So how are we going to... I don't think just yet. You know what we're going to do? Should I do this? Looks like I've got no choice. Let's try it out. This one's going to be hard. The reason why it's going to be hard is because of the actual integral bit. But it is what it is. So make a good note of that. Every time I tell the one that you're going to get as a reduction, which obviously was in 2019, and you won't be able to get it out unless you know the trick I'm about to pretty much say for this question. So it's not like this log reduction where you just did it and it was fine. With your algebraic reductions, there is a trick that you need to be aware of when you're about to do your actual integration. So this one's a little bit harder to complete. Okay. It's got nothing to do with reduction. You just got to run through all of I guess all of your integration topics and say which one you think that one is. You know, substitution and by parts, trig substitution, completing the square, partial fractions, everything. I'm not going to say nothing until you guys think about it for a little
That's
bit.
an inverse 10, right?
Inverse 10, 1 plus.
Oh, oops.
Close. And obviously this would have been an inverse sine.
Yeah.
So, no. Come on, give me some things. Just say them out loud and then go, well, this one won't work because of this, and this one won't work because of this, and then you'll be surprised. Ben, you can give it a shot. Go.
Partial fractions, yeah.
Say it again.
Partial fractions.
Do you think it is or it isn't?
It is.
It is partial fractions. You're absolutely correct. And how do you know that?
Because you can expand the thingy, and they'll give you 2 linear.
You are
things.
correct. That's exactly how I would have seen it. So the fact that you can factorize the denominator into this and this, once you see these denominators, you're like, well, that just reminds me of partial fractions. So that question is actually hidden partial fractions that you've got to realize. Why this one doesn't work? Because you can't actually factorize a 1 plus x squared. That's why it becomes an inverse tan. right? And the other one obviously has a square root and so on. So this one, it's actually factorizable, which comes to linear. And then what do we do, Ben? Make it equal to?
A, B, and C, right?
Ooh,
Oh, A
no,
over 1 plus X
plus,
plus B over 1 minus X. Yeah.
plus b on 1 minus x, and then 1 equals a times 1 minus x plus b times 1 plus x. You let x equal to what to get rid of this one?
You let it equal 1.
X equals to 1, therefore 1 equals 1 plus 1 to b equals to a half.
And then you
You
can
let
just
x
substitute
equal
more.
to
Oh, wait,
minus
never mind.
1, almost. X equals minus 1, you get 1 equals 1 minus minus 1 is 2a. A also equals to a half.
Yeah.
Now you've got this equals to 0, half a, which is 1 on 2, 1 plus x, plus 1 on 2, 1 minus x. And then, of course, we remember these are logs, so you've got a half in front of us, so it's half log 1 plus x. That's negative 1, so that's meant to be minus half log 1 minus x. And what do we sub in?
Half and 0.
Half and 0. Okay, half log half 1 plus half is 3 on 2 minus half log half minus sub in 0 half log 1 minus log 1. What's the answer to that?
Will that be 0, right?
Log
Would
1 is 0 anyway, so 0 minus 0 is just 0.
0.
So you end up with this result, and then, I mean, I can make this look really a little bit easier, I think, for us all. You could leave it like that, but again, seeing that we have been doing logs, you guys should know, you've got two logs, it says half log and minus half log. You can, when you subtract, it's the same as dividing the insides. So your answer becomes half log 3 on 2 divided by a half. Right? And it's subtracted, you could divide. 1.5 divided by a half is just 3. So your answer is half log 3. That's that question. I'm just going to, I'll go back, I just want to take a screenshot of that, paste it down here. So I think going back and forth. All right. So, IN equals this. Show that IN minus 2 minus I of n is equal to this. Okay. Okay. Let me recall how to finish this one off. So IN equals 0 half x to the n on dx. All right. Just give me a second. Let me work something out and I'll explain in a second. Yes. All right. I'm pretty happy with that. What should happen? Yes, I believe so. Okay. So these ones are not by parts. So your algebraic versions are not by parts. If you want to think about it, I mean, if you can see why won't be, your u, let's just say you decide v would have been dx on 1 minus x squared, which itself is already hard to integrate. You know, we just integrated it above, but that's already hard itself. Oh, yeah, you wouldn't want to do that. And then if you want to, if you want this to be your dv, you're only going to increase it in power, so you're going to get like n plus 1, and you're not going to get any closer to n minus 2. So this one here isn't really done by parts. Same as last year's HSC question. It will not have been done by parts. This one is my plus 1 minus 1 trick. The reason why we do the plus 1 minus 1, what I was telling you guys last time is if I've got the same power, try to do plus 1 minus 1, right? If I say there's an x on the top and x, same power, plus 1 minus 1. This comes from that family because now this n can be any power. So at least if it's 1, it could have been done by substitution. If it was not there, so if it was 0, great, that's even easier, you just did it above. But if it's anything higher than 1, which means if it's 2, 3, 4, 5, 6, 7, and literally every other number, the only way you're going to be able to do that is using plus 1 minus 1 trick, which is how this one's going to be done. Now to do it, a lot of students struggle with it, but if you do it the way I explained it, which was force the bottom and then adjust, it's actually not that bad. So 0, half. You've got 1 minus x squared. Now this, write it exactly as the bottom. 1 minus x squared. Now you weren't meant to have x to the n. So what must you multiply this whole thing to get x to the power of n? Well, I would have at least had to multiply it by x to the power of n minus 2. I want to stop there. Can you guys see why I multiplied it by x to the power of n minus 2? Look at the expansion of this and think about why I just did that. So first step, make these two the same. Second step, you're trying to get back to your xn. Can you see why I multiplied it by this? Can someone tell me why I did that?
So you can get to x to the power of m.
Yes, all right, n minus 2 plus 2, I'm back to x to the n. You ignore the signs, don't worry about the signs. The signs are so easy to fix. Can you see that? Rosemary, can you see that? Stefan, all of you guys, can you actually see how when I expand to here, I get xn? It's really important that you see that. N minus 2 plus 2 back to xn. Now there's a negative there. How do we fix that? Well, put a negative there. So when this is expanded, that becomes a positive. Not a problem. Easy fix. Done. But What do we have extra now? We've got this extra xn minus 2. So what am I going to write here? I've got when I expand this, I've got an extra xn minus 2. Greg, what do I write?
Sorry, Sam. Can you say that again, please?
So when I expand this,
Yep.
I'm going to have an x to the n minus 2.
Mm-hmm.
I was never meant to have that.
Yeah.
So how do I counter that? What am I meant to add or subtract here?
You subtract x and n to the power of negative x to the power of negative 2. Yeah, n minus negative 2.
X to the n taken off. Yeah.
Sorry.
Done. Stop and have a look at that. That's some serious algebraic manipulation there. Right? And you can see why it's in question 15. Question 15 is definitely 90% plus. So I'm trying to get you guys to that level. Right there. Raw. But you've got to be able to execute that line exactly the way I just showed it. Not one step more, not one step less. Cannot be done any differently. First step, match. We did. Then you want xn, so adjust, multiply by xn minus 2. Yep, that gets me xn. Into a negative. Now when you expand this, this will become a positive, so not even a problem. But when I expand these two, that gets me xn minus 2. I never had an xn minus 2 here. So I've got to subtract an xn minus 2. Any questions? Stefan, any questions from anybody?
No.
Seriously, that makes like a lot of sense.
Yeah, it's just like that first part, but then the minus x and minus 2, like if that makes sense.
And then what about the first part? Like, let's give you another one. Hold on, let's give you another one. Let's go, if I gave you x cubed, 1 minus x squared, right? If I said, hey, go integrate this, you're going to say, okay, it's going to be what? Next line, integral 1 minus x squared. You've got to make them the same. So what are you going to write on the top?
1 minus x squared.
Then you're like, well, I didn't need that. I needed x cubed. So you times this one by?
X.
Right? Because then you're going to get x cubed there.
Yeah.
Now, don't worry if it's negative. Like, that's easy, I keep saying. That's not a problem. But you're going to have an extra what here?
1.
No. You're going to have an extra, think about the
Oh,
extra.
x, sorry.
You have an extra x. So you don't want an extra x. So look, you're going to have this.
Yeah.
You don't want that. So you're going to, what are you going to do here now?
Minus x.
Minus x. And then look what happens. These two would cancel out. The negative would go back in. Negative and a negative makes it back into a x cubed. So you get back to the original equation. So technically, I haven't changed the equation because that's not allowed. You can't just go from here and get something else. But by me doing all of this, I have actually changed it a fair bit. Okay. Better? Makes more sense this way, doesn't it?
Yeah.
So you got to remember, if it's a 2, if they match or higher, plus 1 minus 1 trick. If it's lower, if it's just x, you can probably see that's a u substitution because when you differentiate this, you're going to get this. X dx is right there. You know? So it's just if it matches or higher, it's plus 1 minus 1 trick. Okay, anyone have any questions for us?
So if the power of the denominator matches or is higher than the power of the numerator, is that what you're saying?
Say that again? Yeah. Wait, if the power is the same or higher, it will always be, look, so here's another one.
Oh, that's
How do we
yeah, they
integrate
match.
this?
So you have to do the plus 1 minus 1, right?
And then plus 1 would be in line with this, minus 1. So the way we're going to rewrite this is literally that, which cancels out, that's the whole point, minus 1 on. So you're actually integrating 1, which is just x, and you're integrating this, which is inverse tan.
Oh yeah, that makes a lot of sense.
Yeah, and that's why otherwise at the beginning you're stuck. You can't do anything with it. All right, so we are here. Okay, split up exactly the same way I just showed you down there. So negative half 0, obviously these two minus these two. So 1 minus x squared xn minus 2 over 1 minus x squared. But look what happens now, right? We got rid of the denominator. That's why we match. But anyways, minus xn minus 2 on 1 minus x squared dx. Okay, any questions there? Split up denominators. No, we're good. All right. Here we go. These two will cross out. So you're left with negative 0 half x to the n minus 2. Well, that's very easy to integrate. You know, you just add 1, divide by the power. Minus this thing. And that is not easy to integrate. Because what you just did is you made it n minus 2. But that's not a problem, because look what we had. We had in was 0 half xn on 1 minus x squared. That looks exactly the same as the original. Instead of it being n, again, it's n minus 2. So what I'll do, like we had done before, with my integral, right? So this becomes negative, just so it's a bit easier to see. There. Negative and a negative makes it into a positive. How can I write this one? And look, how would you write this now? You know, it's exactly the same, except it's
Just
not
in minus 2.
Plus in minus 2. This one here, normal integration. So minus x to the power of n minus 1 on n minus 1. Right? Add 1 to the power, divide by the power. Equals, bring a half down, half to the power of n minus 1. Oh, let's just scroll down. So far we've got in equals, right, negative. Bring the half in, so half n minus 1 over half take away 1 is negative half plus in minus 2. At this point, when I see this algebra, I stop. I go back to the original expression and just to see what they wanted, and then I'll start working my algebra to match the algebra they wanted. So I would go up. They wanted in take away 2 minus in take away 2 minus in to equal 1 on n minus 1, 2 to the n minus 1. 1 on n minus 1, 2 to the n minus 1. Okay, what do I have? Let me have a look at this. I've got a plus sign here. If I bring it over, that becomes that. So probably bring this guy over and plus this guy over. Okay, and then 2 to the n minus 1. Interesting. Okay, let's do it. Let's try. So my thinking is, well, I think you guys would have first made these two negatives and simplified that. So I think we can do that. You know, negative and negative half. So it becomes positive 2. You guys get that? Negative 1 divided by negative half. That is positive 2. Times by 1 on 2 to the n minus 1. Something's gone wrong. 1 on n minus 1. Something has gone wrong. 0, 0, 0. When I started, sorry?
Didn't you have to minus 1?
Don't you have to minus 1? Oh, yeah, half minus 1. No, wait, what? Wait, what are you talking about?
Oh,
Where?
wait. Oh, no. I was talking
Ah.
about... Oh, no.
Just realized. All right, very bad, but there you go. Look, I got myself confused. X, what are you meant to sub this into? X's or N's? When you're subbing in these halves and zeros, where do they go? X's or N's? Come on. Yeah, the X.
X's.
X's. Why did I sub it into N? I got half take away 1. What the heck? No, that's wrong. Just Control Z, whatever. Let's fix that up. Ah, I really wanted that then. Yeah, well. Alright, back to this. It's negative half n minus 1 over n minus 1. And then plus in minus 2. And what we wanted was this. And that's how we're going to still have n minus 1, because it's still meant to be there. 2 n minus 1. That's a lot better. Okay, well, I think we actually have it now. That's a lot easier. So can you see it's in minus 2 minus in? So this is positive. I'm going to subtract that. So I'll be left with in minus 2 minus in. This minus this. I'll plus this to this side. So I'm left with 1 on 2n minus 1 all over n minus 1. And I think you guys by now know denominator, combine your denominators. So the answer becomes 1 on n minus 1, 2 n minus 1 equals, there we go. Any questions? Okay. And I think there was a third part to this question. Third part was, okay. Let's copy it again. The way you read the third part is, of course, the n's replaced for 4. So you're essentially finding I4, right? N is replaced for 4, so you're finding I4. You know that I4 take away if is 4. I hate the way they've written it. See how I don't really like it like this? So I don't think you guys would like it either. What I would be doing is making I4 the subject, but I'll do it this way. But it's not what I would have done. So n is 4. So this would have been 4 take away 2. So I2 minus I4 equals 1 on 4 take away 1, which is 3, times 2 to the power of 4 take away 1, which is 3. I0 minus I2. So to work out what 2 is, 2 take away 2 is 0, minus I2 is equal to 1 on 2 take away 1, which is 1, 2 to the power of 2 take away 1, which is 1, so it's just 2. The only thing you don't have is I0, but I0 is equal to 0 half x to the 0 on 1 minus x squared. X to 0 is 1. 1 minus x squared is the answer that we had worked out at the beginning, wherever that was, half log 3. And pretty much it's just a matter of subbing it back in now. So half log 3 minus a half equals I2. I brought this guy over, brought this guy over, and then I2 is half log 3 minus half minus this guy, 1 on 3 times 8 is 24 equals I4. And then just simplify that. Negative half minus 1 on 24 is negative 13 on 24. And you're done. All right, starting next week, I'll save this. Starting next week, we will be integration by reduction formula. We'll start revising